Hi everyone, today we're going to study ellipse with center at origin and vertex on x-axis. First, let us define ellipse. An ellipse is the set of all points in a plane such that the sum of its distances from two fixed points in the plane is constant. The fixed points are called foci, plural of focus of the ellipse. Here we have 2 points arranged horizontally, and we consider this as the foci of the ellipse. Let us draw now the ellipse. Here we have the ellipse. The line through the foci is sometimes called focal axis. Here is the line, and this is the focal axis. The point on the focal axis, midway between the foci, is the center. Here is the center. The points where the ellipse crosses its focal axis are the vertices. So we have 2 vertices. This is the first vertex, and this is the second. The line segment joining the 2 vertices is called major axis. This line segment in red is the major axis. The line segment through the center, perpendicular to major axis, terminating at the ellipse, is called minor axis. This line segment in green is the minor axis. Now let us define eccentricity. The eccentricity, denoted by E of a curve, tells us the amount of roundness of that curve. Take note that the eccentricity of circle is 0. The eccentricity of parabola is 1. The eccentricity of ellipse is between 0 and 1. And normally, you will see this symbol in the books. E is between 0 and 1. Take note that a small eccentricity indicates that the ellipse tends towards being circular, whereas an eccentricity close to 1 indicates that the ellipse is elongated. Let us now consider ellipse with center at origin and vertex on x-axis. Here we have the x and y axis. This is our ellipse with center at origin 0, 0. Next, we're going to draw the foci. This is the first focus denoted by F, and this is the second focus denoted by F prime. If we consider the line segment connecting this foci, we denote this as 2C. By then, we can write the coordinates of F and F prime respectively. So for the F, it will be C0 coordinates, and the F prime is negative C0 coordinates. Next, let us pick one point of the ellipse, and we denote this by P with coordinates xy. This point P represents all the points of the ellipse. We will get the distance of this moving point from the first focus F, and also the distance of this moving point from the second focus, f prime. By definition of ellipse, we say that the distance fp plus the distance f prime p is always constant. So we write here equals k. The standard equation of ellipse with center at origin and vertex on x-axis is given here. So this is x squared over a squared plus y squared over b squared equals 1. The derivation of this equation is presented in the other video. Now, let us write the vertices. This is the first vertex and this is the second vertex. We know that the vertices are the points where the ellipse touches the x-axis. We denote the first vertex to be V and the second vertex to be V prime. The line segment connecting these two vertices is called major axis. And if we denote this by 2a, we can now write the coordinates of the vertices. So the V will have the coordinates a0 and V prime to be negative a0. Next is the points B and B prime. These are the points where the ellipse touches the y-axis. Now, the line segment, this is the green one, connecting this point B and B prime is called the minor axis. And we let this to be 2B. By then, the coordinates of the points B and B prime are 0B and 0, negative B respectively. Now for the latus rectum, the plural is latera recta. There are two latera recta here. The length of latus rectum, abbreviated by LLR, equals 2b squared over a. That is the length of this latus rectum. The endpoints of latus rectum for the first one is here, c, comma, b squared over a. The second endpoint is c, comma, negative b squared over a. For the second latus rectum, the endpoints are negative c, comma, b squared over a, and this one is negative c, comma, negative b squared over a. For the eccentricity denoted by E, this is equal to c over a. Let us see this example. Find the equation of an ellipse with center at the origin, foci at positive or negative 3, 0, and vertices at positive and negative 5, comma, 0. Then find the length of latus rectum, eccentricity, and sketch the graph. For our solution, let us draw that ellipse, the center at origin. The foci are here, the 3, 0, and the negative 3, 0. The vertices at 5, 0, and negative 5, 0. Let us now write the standard equation of the ellipse. In this equation, we need the value of a square and b square. We know that a is the distance from center to vertex. The center at origin and the vertex is 5, 0. It means a equals 5. In this problem, the given are the foci, which means that is the C, and that is equal to the distance from center to focus. From origin to one focus 3, 0 is equal to 3. So we need to solve for B. Solving for B, and we will use this Pythagorean relation, a square equals b square plus c square. Substituting the values, we have now 5 square equals b square plus 3 square. This 5 square is 25 and the 3 square is 9. Solving for b square, we will transpose this positive 9 to the left side. So we have 25 minus 9 equals b square. The difference is 16, and if we take the square root of this equation, we will get the value of b equals 4. So this b here, we will use to substitute in here, and the value a is already given in the problem. So the a square becomes 5 square, and that b square is now 4 square. 5 square is 25, and here it becomes 16. Take note also that our major axis equals 2a, and the 2a equals 10. Also, the minor axis equals 2b, and this 2b means this is equal to 8. The length of latus rectum, or we say LLR, equals 2b square over a. Substituting the values for b and a, we have now 2 times 4 square over 5. Simplifying the numerator, we have now 32 over 5. This is the length of latus rectum. Now, the endpoints of this first latus rectum can be solved by this formula. Also, the endpoints of the second latus rectum, the formula is here. Substituting the values, we have now this point to be 3, 16 over 5. The second point here is 3, negative 16 over 5. For the second latus rectum, one endpoint here is negative 3, 16 over 5, while the second endpoint is negative 3, negative 16 over 5. For the eccentricity denoted by E, this is equal to C over A. Substituting the values, we have now 3 over 5. These are our final answers. I hope you learned something from this video. See you again next time.